Please, as a reminder, do not share any personal information during class. All right, as we have already experienced, we want you guys participating and that these class sessions are recorded for educational purposes. Let's look at what we're doing.
All right, so today we're going to be taking a look at Newton's second law of motion. I do apologize. Yesterday, instead of uploading the Unit 2 project, there was an error, so I gave you a day to complete missing and failed work. So hopefully you got a chance to use that yesterday wisely to get some stuff done. We do have spring break coming up, so after this class, if you have all of your work done for the day, I hope you have a wonderful spring break. We will see you back on April 6th. So this following Tuesday is when school starts back up. So you do get that Monday off, but you should be back here on that following Tuesday, April 6th. All right, so let's go ahead and again, there was an error with the instructional videos for the project, so don't worry about the project right now. We will go ahead and we will work on that a little bit more after spring break.
All right, so for our unit today, we are going to be looking at Newton's second law following the first law from last lesson. We're nearly halfway through the unit, so we're just moving right along. All right, and specifically today, we are going to be explaining how mass, force, and acceleration are related. We're going to define and apply Newton's second law of motion. We're going to learn what that is in a little bit. And then we're going to complete calculations using the equation F equals ma, or just as we'll learn a little bit, that means force equals mass times acceleration. And hopefully by the end of all this, our notes quiz should be an 80% or higher so that we can demonstrate that we have learned and mastered these concepts.
Okay, so as mentioned, when we are doing our notes, remember we do need to be doing them during class and passing them during class. Otherwise, we will not be able to also get attendance credit. Remember, if you want both types of credit, you need to do it during class. Go ahead and open those up. Links are in the chat box. You have 20 more seconds to raise your hands, or if you're on your phone, send me a chat. Raise your hands, or if you're on your phone, send me a chat. Go, go, go. Okay, so what I want to know in the main chat, if you've ever played Mario Kart Balloon Battle, how many of you have ever played that? I loved this as a kid on N64. Yes. Awesome. I think we actually have it on Wii too, which we have a Wii now, so I should try to play it on Wii with my daughter. I think she'd get a kick out of it. Yeah, so in Mario Kart Balloon Battle, what I want you to think about is if Toad and Bowser, all right, are at the starting line facing each other and they drive towards each other, who is going to squish who with more force? Okay, so tell me in the chat who squishes who. If Toad and Bowser both accelerate at the same amount towards each other, same speed, who's going to squish who? Yes. Tell me in the chat. So we're taking a look right here. If you're not familiar with this, you can see pictures of them, Toad and Bowser. So if we have a tiny Toad, big Bowser coming towards each other, who squishes who? Bowser gets squished? No. Bowser does the squishing, right? Smiley faces if that makes sense. Bowser would win this, right? So Bowser wins. Bowser wins here for Toad versus Bowser because Bowser's a lot bigger, right? He's a lot bigger. Now, on the other hand, let's say that we have DK versus Bowser, all right, facing each other. And this time they are about the same size, right? They have about the same mass. But remember that in Mario Kart, if you press the button at the right time, right before it's before it says start, if you press the button at just the right time, it will let you have a boost, right? It'll speed you up a lot faster, right? So let's say that DK this time gets that boost and has a really large acceleration, whereas Bowser kind of stalls and has a really small acceleration. This time, who squishes who? Who wins this time? Tell me in the chat. Who wins? Awesome. Yes, yes, yes. This time DK is going to squish Bowser because he's moving way faster, right? So even though they're the same size, right, this time DK wins because he had the acceleration and went a lot faster, whereas Bowser stalled in place. Bowsered? Oh my goodness. All right. Cool. All right. This is going to be related to Newton's laws of motion. Here we go.
All right, so moving right along with Newton's 3 laws of motion, we are starting to learn about the second law. All right, specifically the second law says there is a relationship between an object's mass, its acceleration, and the applied force. So if we look at the second law, right, the acceleration of an object is dependent upon the net force acting upon the object and the mass of the object, right? So just like with the Mario Kart, if something has more mass, right, generally if we increase the mass, we're increasing the force, but we can also increase the force if we increase its acceleration. So you can think about that if we have a very tiny object, but if that very tiny object is moving very, very fast, it will have the same force as if a larger object that is traveling slower, right? So that's kind of what we're dealing with right now. Let's learn a little bit more about it right here.
All right, so in order to cause an acceleration or a change in velocity, right, we reviewed that definition at the start of class, we need an external or outside forces. Remember, we said throughout the last few lessons that forces cause acceleration. Now, when that force causes an acceleration, that force depends both on the acceleration of the object as well as the mass of the object, right? If I apply a certain force to a really big object, it's not going to accelerate as quickly as if I apply that same force to a really small object, right? So if I kick a soccer ball with a light mass, it's going to accelerate pretty quickly. If I try to kick a bowling ball, which has a big mass, it's not going to accelerate as quickly, all right? So this actually has to do with our things that we just talked about. So taking a look here, if we change mass, all right, but keep the force if we change mass, so Toad with a small mass and Bowser with a large mass, but they have the same acceleration, then the winner is going to be the one with the larger mass because that'll make a bigger force. Okay, so he will win. On the other hand, if we were to change acceleration and keep the same mass, like with DK and Bowser, right, the one with the larger acceleration this time was the winner because he ended up with more force. So all of these things, mass, acceleration, and force, are related to each other. Give me a smiley or an emoji in the chat box if that makes sense. We'll talk about exactly what those relationships are called in just a moment. Smiley, emoji in the chat if that makes sense. If you change mass, it changes force. If you change acceleration, it changes force. If you change force, it changes acceleration. All right, they're all related to each other. Excellent. I see Lena. I see Cody in the chat. Smileys, emojis, if that makes sense. Yeses. Thank you, Shayna. Perfect. All right. Thank you, Jonathan. Yes. Let's go ahead and fill in number 2. Number 2 is the word external and only the word external. Make sure you fill in that blank correctly. You have 20 seconds to raise your hands for number 2. Go, go, go. Newton's second law of motion, as mentioned, is this idea that force is related to mass and acceleration. Specifically, Newton's second law is actually an equation. The equation is that force equals mass times acceleration, or F equals ma, one of the most famous physics equations. Maybe E equals mc squared is more famous, but F equals ma is a pretty close one. All right, so taking a look here, some things that we need to know here. Force is measured in newtons. We talked about Sir Isaac Newton on Wednesday, so we have named this unit of force after him. So newtons, for example, 3N would mean 3 newtons. Mass, we learned in our first unit, is measured in kilograms. So, for example, 10 kg stands for 10 kilograms. That would be a mass. And acceleration, we learned a couple lessons ago, is meters per second squared. Again, that squared is just on the unit. You don't actually need to square any numbers. It's just a part of the unit. So 5 meters per second squared, for example, that is an acceleration. Again, that squared has nothing to do with the math. It's just a part of the unit. Now, taking a look here, what we just saw is that force and acceleration are directly related. The more force you apply to something, the more it's going to accelerate. Think about this, all right? If I try to push a friend, right, and I just kind of nudge them with very little force, are they going to move very much? Tell me in the chat. If I'm trying to push a friend into a pool, for example, and I just nudge them, are they going to go into the pool? Yes or no? No, right? So if I have very little force, then I'm not going to have very much motion. I'm going to have very little acceleration. So only a little force means only a little acceleration. On the other hand, if I give a lot of force and I push them really hard, then will they accelerate into the pool? Yes or no? If I push them really hard, will they begin to fall into the pool? Yeah, because this time I added way more force. So more force results in more acceleration. This is what's called a direct relationship, because when one increases, the other one also increases, or when one decreases, the other one also decreases. So that's what's again called a direct relationship. They are directly related to each other. Now, mass and acceleration, on the other hand, are inversely related to each other. So let's think about this, right? Again, we talked about our soccer ball versus our bowling ball. If I try to kick a soccer ball versus a bowling ball, which one goes further? The soccer ball, which is lighter, or the bowling ball, which is heavier? If I try to kick a soccer ball and a bowling ball, which one goes further? Well, definitely the soccer ball, right? So the soccer ball only has a little bit of mass. So when I kick it, it's going to accelerate really, really far, right? That's why a soccer ball is so good at flying across a field. On the other hand, if you take a look at my bowling ball has a lot of mass. It's much heavier. And so when I kick it, it doesn't go nearly as far. In fact, it probably will injure me. I'll end up with a lot less acceleration. So this type of relationship is called an inverse relationship, where when one increases, the other one does the opposite. So as we get more mass, we actually get less acceleration. Or vice versa, with less mass like a soccer ball, you actually get way more acceleration. Go ahead and give me a green check, orange X if that's beginning to make sense. Again, a direct relationship, they both increase or they both decrease. Inverse relationship, they do the opposites. One increases, one decreases, or one decreases, the other increases. Green checks, everyone, if that makes sense. I have 50% of green checks. Excellent. There we go. Perfect. All right, let's go ahead and fill in number 3. Please fill in the first blank with the word directly and the second blank with the word inversely. Capitalization does not matter, but spelling does, so make sure to spell them correctly. You have 40 seconds to fill in both of those blanks. Go, go, go.
Enabling our whiteboard tools, so make sure you know how to do this. Remember, choose the box icon, smallest font, use the line, and draw a line from the terms of definition. We have terms here such as Newton's second law of motion, definition of acceleration, more force equals more acceleration, and more mass equals less acceleration. All right, we're going to match these to our definitions, in which we have options such as any change in velocity, a direct relationship, F equals m times a, and an indirect relationship. All right, yeah, so let's check our work. All right, yeah, so Newton's second law of motion is F equals ma. So the formula F equals ma is Newton's second law of motion. The definition of acceleration, right, is just any change in velocity. That's what acceleration is. And then we have our last two, which is describing a type of relationship. So a direct relationship is when more force equals more acceleration, right? So based off that equation, if we increase acceleration, it will increase the force. That's what that is describing right there, a direct relationship. And then more mass going to less acceleration, that is an indirect relationship. Let's make sure we mark this for number 4. All right, make sure you raise your hands. I'll give us a timer.
All right, so we have quite a few practice problems and a couple problems that you need to do on your own. So please make sure that you have a calculator out, either on your phone, on your computer, or you can also Google the word calculator and a calculator will pop up. So the question is, what is the force needed on a 5-kilogram box in order to accelerate it at 0.8 meters per second squared? Let's annotate this together in the chat box. Kilograms, is that a mass or an acceleration? Tell me in the chat, kilograms, is that a mass or an acceleration? Yes, this is going to be our mass, so I'm going to plug that in down here for m, mass. And 0.8 meters per second squared, what is that? Tell me in the chat, what is that? Thank you, Jonathan. I see you in the chat. I see, let's get some more people in the chat. Meters per second squared, that's our unit for what? Yes, this is our unit for acceleration. So I'm going to go ahead and plug in 0.8 for my acceleration. Again, that squared is only on the unit. Don't actually square any numbers. Do not square any numbers. But grab your calculators. What do we get when we do 5 times 0.8? 5 times 0.8. Thank you. I see Jonathan in the chat. Yeah, this is going to be 4. And remember, our units for force are newtons, right? So may the m times a be with you. May the force be with you. This is going to be the answer to number 5. Go ahead and raise your hands for number 5. You have 20 seconds to fill in the the number 4 and the unit n. So the number is 4, the unit is n.
Annotate it. How much force is a 950 kilogram elevator experiencing if it's falling at a rate of 9.8 meters per second squared? Remember, this is acceleration due to gravity. So we have our mass. So yes, we do have kilograms for mass, and then acceleration. we're going to have that be 9.8 meters per second squared. So we're going to put that over here for our acceleration, right? And then we're going to multiply those together, and then we're going to get our answer in newtons. Yes. Yeah, you guys are getting it. It looks like you guys are getting the correct calculation. Yeah, it will be 9,310 newtons. Make sure to mark this answer for number 6. All right, it is 9,310 newtons. Remember, no naked numbers. Remember those units are in newtons. It is a capital N. Please mark that for number 6. Raise your hand when you are done.
All right, so for this one you need to complete on your own, but as always, we're going to go ahead and annotate it together. Okay, Tim, we can go back to it after class. So the question is, what is the force that a 45 kilogram skater must exert in order to accelerate at 5 meters per second squared? Tell me in the chat, kilograms is my unit for what? Kilograms is my unit for what? Force, mass, or acceleration? F, M, or A? Tell me in the chat. Thank you, Cody. Need more answers. What is kilograms for? Thank you, Joseph. Thank you, Lena. Yes, 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 exactly. This one is going to be our M for mass. And what about meters per second squared? This is our unit for which variable? Force or acceleration? Those are our two left over. Force or acceleration, meters per second squared. Excellent. I see Joseph, Angelina, Cody. Yes, this will be our acceleration. Obviously, it's not going to be our force. Force is actually what we're solving for. So taking a look here, plugging this in, force equals mass times acceleration. I should have 45. And my acceleration right here. Please finish up this problem. Don't forget the number goes in the first box, the letter N goes in the second box. Do not put answers in the main chat, please. If you need to check your answers, we are in the Q&A chat. This is the answer to number 7. Raise your hands. You have 30 seconds. All good, Kalina. Now, we can also use this equation to actually solve for acceleration. So anytime we have an equation, remember, we can solve for different variables. So let's say that this time we want to know how much will this sled accelerate if it's a 7 kilogram sled and I'm pushing it with a force of 31.5 newtons. So let's go ahead and take a look here. 7 kilograms in the chat. Kilograms is the unit for what? F, M, or A? Force, mass, or acceleration? Kilograms is always the unit for what? Thank you, Cody. Thank you, Angelina. Again, practice this because you will need to do the last one on your own. Thank you, Jaime. Yes, this one is going to be our M, our mass. And this time we have it being pushed with 31.5 newtons. This time, what does our unit newtons mean? Is that a force or an acceleration? Newtons, is that a force or an acceleration? F or A? F or A? Thank you, Cody. Yeah, this will be our force. So let's go ahead and plug this in. All right, so underneath my force, I'm going to put in 31.5. And underneath my mass, I'm going to put in 7. Now, the problem is this is not a simple problem where we can just do multiplication. We do need to do a little bit of algebra here. So taking a look here, I want to get acceleration by itself. Currently, what's next to it is multiplying by 7. So I need to do the inverse or opposite of multiplying to get rid of the 7. Tell me in the chat, what is the inverse or opposite of multiplying? What is the inverse or opposite function to multiplying? Thank you, Jaime. Thank you, Cody. Angelina. Yeah, we're going to divide. So instead, we're going to go ahead and divide by 7. All right, and that'll get rid of it. But here's the thing, we have an equal sign here. So whatever I do to one side of the equal sign, I also need to do where to keep things balanced. Whatever I need to do to one side, I also need to do where? Yeah, to the other side. So I'm also going to do the same step and divide by 7 on the other side. So tell me in the chat, 31.5 divided by 7, what do we get here? 31.5 divided by 7, what do we get? What is my acceleration here? Thank you, Jaime. Thank you, Cody. Again, make sure you know how to use your calculator. Make sure you're following along. That way you can do the next problem on your own. Thank you, Seraphim. Lena. Yeah, this is going to be 4.5. Now, just so you know, the number obviously goes in the first box. However, for the second box, the way that you're going to write this unit is meter/seconds with a caret. You can get that by pressing Shift and 6 at the same time. And then the number 2. All right, so this is what actually goes in the second box. Otherwise, the computer will mark it as wrong. So have a caret in between that S and that 2. This is the answer for number 8. Please raise your hands. For number 8, you have 30 seconds. Go, go, go.
5 kilogram bowling ball is rolled with a force of 12 newtons. What is the ball's acceleration? So that's going to be our mass. That's going to go right there. And then newtons, that's going to be our force. So that is on the other side of the equation. We're going to need to divide them. So if we take this and rearrange the equation, right, we should get that acceleration equals force divided by mass if we rearrange it, right? So that means we have to take our 12 newtons and divide it by our 5 kilograms to get our acceleration. Let's go ahead and do that calculation together. It is 2.4. So we're going to have that over here, 2.4. Remember, that's going to be the number part of your answer for number 9. And then the unit part is going to be meters / seconds squared. All right, but remember that to show the squared in your answer, you could also put a caret, just like Mrs. Larkin has demonstrated for us in the chat.
All right, so this one you'll need to finish on your own, but as always, we'll go ahead and annotate together. So we have a 2-kilogram ball that is kicked with a force of 7 newtons, and the question is, what is its acceleration? So kilograms, is that going to be my F, my M, or my A? My force, my mass, or my acceleration? Again, we've practiced this 5 times now, so what is kilograms? Yes, kilograms is our mass. And what about newtons? Newtons is our what? Our force or our acceleration? There we go. Yes, this one is going to be our force, F for force. So again, we would plug in for force our 7 and our mass, we're plugging in our 2. All right, so taking a look here, again, I need to get rid of multiplying by 2. So what would I need to do to both sides? If I need to get rid of multiplying by 2, what do I need to do on both sides? Yep, divide by what? Divide by what number is currently next to our acceleration? Yeah, so we need to divide by 2 on the right and get rid of that, and we also need to divide by 2 on the left. So that should help you figure out number 10. Go ahead, grab your calculators, calculate number 10. Do not put answers in the chat. Remember that the units that you are going to put in should be written as meters per second caret 2. Meters per second caret 2. That's what you should plug in, for your units. Please raise your hands for number 10. Go, go, go. You have 30 seconds. Go, go, go.
We learned this formula, we learned how to use it and calculate different parts of it, including rearranging it using algebra. All right, if you haven't already, please go and submit your notes if you are ready to.